All right, so again, a family reunion photo of Saturn's moons. It was actually during a picnic held by our moon, as you can see. Iapetus and Mimas. There's Mimas, which is responsible for the Cassini division. And Enceladus, which also plays a role in some of those moons. And again, just as in the case of Jupiter, even though these are pretty similar bodies in terms of composition, they really look radically different from each other, which is kind of bizarre, because they're very much in the same environment. Same composition, only real difference is they have a different distance from Saturn, basically. And apparently that causes a differing amount of radiation effects. That kind of makes sense because Saturn has a strong magnetic field, and so objects that are closer to Saturn are going to be more protected by the magnetic field than ones that are farther away. So they may have something to do with the color variation that we're seeing, which again occurs despite the fact that we are seeing pretty consistent compositions. All right. Primary moons in the solar system, well, I guess I'm just showing this again to emphasize that Titan is actually larger than Mercury, 5,150 kilometers, like 4880 for Mercury, and it's actually the second largest moon after Ganymede. Okay, so here's a shot that shows Saturn with Tethys and Dione, which are a couple of the larger moons. This is the Voyager shot. Again, a type of photo we could never get from Earth because we're seeing shadows of the rings on Saturn. I remember a science fiction film called The Amazing or The Incredible Melting Man. It's not even grade B, it's like below grade B, whatever that is. But anyway, there's the line there. Well, so you might wonder, why does the Incredible Melting Man start melting? Good question. Well, they show some stock footage at the beginning of an Apollo, liftoff, just completely stock footage from NASA. Then they show some kind of stock footage of an astronaut floating around a capsule, and then he radios back. I think it's something like, you haven't seen anything until you've seen the moon through the rings of Saturn, or something completely bizarre. And then, because he saw the moon through the rings of Saturn, he comes back to Earth and, well, he starts melting. It's pretty gruesome, but yes. Again, not even grade B we're talking about. But for some reason, I always think about it. I see these shadows of the ring. Just this way my mind works. Incredible Melting Man. Check it out at a theater, probably not very close to you, because I don't think it's played anywhere anymore. It may not even be on YouTube. That's saying something. Everything. Okay, so again, just a shot of Saturn with a couple of the more distant moons there. By the way, we did talk about why Saturn has this muted type of color variation compared to Jupiter. Worth keeping that in mind because there's a couple of questions on the exam about that. So the bottom line here is that if we contrast Saturn with Jupiter, okay, what we're seeing is pretty similar compositions. We're seeing ices like ammonium hydrosulfide, things like that, water ice. But when we look at Saturn, we don't see the color variations we see when we look at Jupiter's atmosphere. Okay? So the basic reason for that, we think, is because the gravity of Jupiter, the acceleration of the cloud tops, is about 3 times stronger in the case of Jupiter than it is in the case of Saturn. So what that causes is a squeezing down of the atmospheric layer of Jupiter. And then what that means is it's a little easier to see down to deeper layers through the atmosphere of Jupiter because it's more compressed vertically. So you're a little more likely to see the clouds part, if you will, so you can see down to a deeper layer where there might be water ice crystals. So you see the bluish bands on Jupiter. You don't see those in the case of Saturn because it's actually got a thicker cloud deck because the gravity is weaker, so the cloud deck is less compressed. And so you're less likely to see a parting of the upper layers, to allow you to see down to the water vapor layer. So we basically don't see any bluish clouds in the case of Saturn's atmosphere because it's a thicker atmosphere because of the weaker gravity. So I just wanted to kind of mention that by way of review since we're going into the exam on Thursday. Another one of Saturn's moons, Rhea. This was actually visualized from a pretty close distance, again by Voyager. And we're seeing a surface which is basically icy, but been subject to thousands or millions of impacts, which is, of course, typical of bodies that aren't protected by atmospheres in our solar system. And to pick up on Titan, I mentioned that Titan was off the roadmap. We didn't even see Titan. It was just a road sign that pointed to Titan. But what we see here is Titan is very far away from Saturn, and it's not even in the equatorial plane. The equatorial plane of the planet is the plane where the rings are. And this is not an optical illusion, meaning that Titan really is way out of that plane. It's way up at a crazy angle like that. probably indicating that it's a captured object, because it's hard to see how an object like that, oh, this is my cat. Does anybody remember? Amos? I haven't shown her in a while. Do you remember?
Cheddar.
Phenomenal. Very good. I was about to give a hint it's a type of cheese, but you knocked it out of the park. Cheddar. That's my cat. We have 5 cats. It's my special cat. I told her I was going to show the photos of this. Just a random thing. Okay, so just to talk a little bit about space missions that have gone out to Saturn and also the moon Titan, which is very, very interesting to us because, again, Titan has an atmosphere, which makes it unique amongst all of the moons in the solar system. Now, let me see if this actually will work. There's actually been a landing on Titan, which I briefly touched on a while back, and we'll look at some photos. It's actually really significant that we landed on Titan, because remember, it has this thick atmosphere. You can't see the surface of Titan from orbit. Until we landed on Titan, we actually had no idea what the surface of Titan looked like, so we'll look at some photos. But one of the other minor moons, Hyperion, had a flyby take place. Oh, come on, no. I can't accept that. Okay. Switch to Plan B. Another classic science fiction movie, Plan B from outer space. Remember that? It has real significance now because Plan B also can mean something else.
So bad.
Where is it? There. Okay, sorry, I don't know why PowerPoint isn't letting me move to these movies anymore. No problem. No problem. The key to giving a lecture like this is don't panic, even when something goes wrong. Open with time. Okay. So there we go. This is a minor body, Hyperion, and when I saw this, the first thing I thought of was that I thought this was like a Photoshop thing where it's a flyby of a piece of gefilte fish. Looks just like a piece of gefilte fish, but actually it's again an icy moon of Saturn, which is the unique thing about this is simply that it was actually flown by the Cassini mission. That's why we're seeing these ridiculously close-up shots of impact craters and things that took place on the surface there. Craters within craters. Again, this general theme that we have is of extreme bombardment. But you can also see some evidence for icy composition because of the way some of the craters formed and sort of melted back into the surrounding landscape there. And again, some strange things which may be radiation darkening or may indicate rocky material that fell in during an asteroid impact. And let's see if there's else here. Ah, there we go. There goes the giant gefilte fish. Okay. Okay. So now we have flown by Hyperion. Go on. Talk about this mission. So what happened with the Cassini mission was that it actually had this probe called Huygens, which was released from the Cassini orbiter as it flew by Titan and actually floated down through the atmosphere. So remember, there is an atmosphere, so you can use a parachute. And you can't do that practically any place else in the solar system except Earth. You can't even really do that on Venus because of the conditions there. But you're actually able to use a parachute. That by itself is a completely bizarre thing when you think about it. You're in the outer solar system here. You really don't expect to see an atmosphere like that. Okay, so what's really amazing about Titan is that it has a lot of nitrogen. I mean, bizarrely enough, this actually is, in some ways, the most similar atmosphere to Earth's atmosphere, because we have 78% nitrogen gas. Here we're seeing 90% nitrogen gas. Well, actually, that's a lot more similar to our atmosphere than is the atmosphere of Venus or the atmosphere of Mars, which are terrestrial planets. I mean, here this is just a moon, and yet it has a very high density of nitrogen. The surface pressure is about 60% greater than Earth's surface pressure. So even the pressure is pretty much comparable. It's like the pressure being down at the bottom of a swimming pool or something like that. It's higher than Earth's surface pressure, but it's not radically higher. Okay, but obviously there's a couple of glaring differences, like we don't have, the oxygen composition. There's no free oxygen, so in that sense it's completely unlike Earth. And the other thing is the temperature is only 97 Kelvin. That is brisk. That is pretty chilly, because remember that 73 Kelvin is the freezing point. So we are many, many, many degrees down below freezing. And by the way, that is the predicted equilibrium temperature at that distance from the sun. So remember that when we looked at Saturn, we saw a temperature at the cloud tops which was about 105 kelvins. But when we look at Titan, we're seeing the expected equilibrium temperature. So there's no funny business going on with Titan with energy generation, or any of those things that we saw happening in Saturn and Jupiter's atmospheres. But anyway, we do wonder if life could possibly have occurred out there, because we actually see a lot of organic precursor compounds like methane and ammonia gas, things like that. There may be methane snow, oceans of ethane. If you're a high-performance car enthusiast, this would be a good place to go, because you can even make nitrous oxide. That's another good thing, bring the high performance. The reddish color that we're seeing there actually is probably partly due to the methane and ammonia composition. All right, so here's an artist's conception, a kind of romanticization, I would say, of the landing on Titan. You see a parachute bringing the craft down, and of course you see very scenic craggy peaks, and you see Saturn in the background, right? Well, this is a kind of a romanticization, because the atmosphere is so thick you could not possibly see Saturn through that. And the landscape doesn't even turn out to be quite like this. The one thing that's accurate here is there is some sort of liquid on the surface. So this is a shot taken from very high altitude by the lander as it's coming down. And you don't see too much here, but actually analysis shows that this is indicating the presence of land masses and liquid bodies. And now here we're seeing something that almost looks like a view from the scenic overlook if you're taking I-64 west through the Blue Ridge Mountains to get over to Stanton or something. There's a scenic overlook there. I would call this a scenic overlook on a bad day. It's not a really good day there. But you can actually see this region down there that's actually liquid, and we think that's actually literally a lake of liquid ethane there with icy sort of mountains and continents around it. All right, so visual light view of Titan. Don't see too much through the atmosphere. When we use penetrating radar, shot from the Cassini orbiter, not from Huygens itself, again, we start to see the presence of land masses and things that indicate presence of liquid. Infrared actually also penetrates through these cloud layers, because infrared, being longer wavelength, tends to make it through the atmosphere. That fact is completely analogous to the reason that we see red sunsets on Earth. So red light from the setting sun, being longer wavelength, is less affected by scattering and makes it to your eyes. The shorter wavelength blue is scattered all over the place, and that's why the sky is blue. The infrared here, being longer wavelength, pretty much makes it through the atmosphere, and so you can see heat distributions on the surface that suggest that different regions are absorbing solar energy differently. Again, not a lot of detail, but it is a pretty bizarre surface there. And the most intriguing thing is the fact that, again, we have this atmosphere, a dense atmosphere. None of the other moons have that. It's a puzzle as to why this object has a thick atmosphere, or any atmosphere at all, whereas no other moon in the entire solar system does. Well, being in the outer solar system, we think that Titan, being very cold, was actually able to retain its methane and ammonia. That by itself doesn't really explain why it has an atmosphere and some of the others don't. That explanation probably has to do with its size. Remember, it's by far the largest of Saturn's moons. We think the largeness of the size and the requisite increase in its mass, combined with the cold temperatures out there, allowed it to retain some of those gases which otherwise escape. It was probably very close to the tipping point where the gases would escape because of the temperature out there, but with its extra mass, its escape velocity was a little higher than the escape velocity from the other moons out there, and that may be why it was actually able to retain its atmosphere. We think there may be some radioactivity that forms ices and actually helps keep the atmosphere aloft. And there's sort of a chemical reaction, chemical factor in the atmosphere of Titan, because the weak sunlight that you get out there is actually enough to split apart ammonia into hydrogen and nitrogen, which are, hydrogen is highly reactive, and that actually creates a chemical cycle.